Hi everyone. Let's solve today's problem of the day, that is binary tree to CDLL. Okay. So what is the question state is that given a binary tree of n edges, the task is to convert this to a circular doubly linked list. Okay, in place. So the left and the right pointers in the nodes are to be used as previous and next pointers, respectively, in CDLL. So the order of nodes in circular doubly linked list must be same as in order of the given binary tree. So the first node of in-order traversal, that is the leftmost node in the binary tree, must be the head node of the CDLL. Okay, so what is the question state is that basically we have been given a binary tree, right? And we need to convert it to a circular doubly linked list and in place, right? We have to do the changes in place. We do not have to take any extra space. And that's it. Like, and also it has to follow an in order traversal, right? So I'll be telling both what circular doubly linked list is and what an in-order traversal is. So let's look into some of the examples. So this particular linked list is called as a circular doubly linked list. So what exactly is a circular linked list is basically the last node is pointing to the very first node, right? So the last node's pointers next is pointing to the first node. Okay, that is the head node, right? So this is the circular linked list, and doubly linked list is basically it will have three fields inside a node. That is the data, link to the previous node, and link to the next node, right? So I hope it is clear what a doubly linked list is. So a linked list is basically having two pointers, a node pointing to the next node, and the that next node pointing to its previous node further. And circular linked list is basically the one having the last node pointing to its last node's next pointing to its first node, right? That is the head node. So the combination of both of them is given here. And we also have a tree, right? So let's see how we are converting this particular tree into the doubly linked list. So we have this particular test case first, wherein we have 1, 3, and 2. So the in order traversal is left, root, and then right. Okay, so this is how in order traversal is done. That is left. We first visit the leftmost node and then the root and then the right. Okay, so here also we have the left, root, and right concept. Okay, so first we have the root. Okay, so now we have to go to its left. So why? Because first we have to visit the leftmost node. So we are at 3. Okay, so now at 3 I have to go to the left, but we will see that its left is not having any values. So we will come back to its root. Okay, so since it is not null, we will return back and we'll come back to 3, right? So at 3 now I have to process the root. Okay, so for processing the root, I will make the doubly linked list node and we will store it and then move further to the next iteration. So now this goes again back to its parent node. So that is how we print 3 because we are processing the root. And then for 1, we have completed the left hand iteration, right? So now while coming back, now I have to process the root, that is 1, right? So now for processing, we will just print it or make the node in this case of the circular doubly linked list, and then we will go back to the right node, and again we will have the same, we'll have to do the same thing, and then we get the 2. So I hope you're clear how we got 3, 1, 2 as the order, and this is what we have to do for the particular question. So every time I am processing this particular root, I have to make the doubly linked list, right? So we'll be seeing how we will be making that. So for example, we have this particular this thing, the binary tree. So in this case also, we'll be going first to the leftmost node and then coming back to its root. So then we have the 20, and then for this root we also have a right. So in this case we will print 60, and then for 10 the left hand side is being executed. So now we have to go for its processing. So then we'll print 10 and then 30. Okay, so I hope you're clear how the in order traversal works. This is what we will be doing. So let's see what we have to do, right? So You're familiar what a in order traversal is: left, root, and then right. Okay, so this is the algorithm that we have to follow. Obviously we will have to take two pointers, right? So two pointers, what does that mean? First we will have a previous pointer and a head pointer. So what exactly is a head pointer? Basically, when I'm creating a linked list, we have to have a head pointer, that is the first node of the linked list. So this is the head pointer that we have, right? A head pointer, and this will be the a previous pointer will be used in order to traverse through my linked list, right? Or we can say the given binary tree, and to make the linked list. So now we have to iterate in order traversal. So whichever tree we have to iterate through it in an in order traversal, and for every processing node. So what do I mean by process node? That means whenever I'm getting a root value, okay, so whenever I'm getting a root value, in that case, what I have to do is I have to make the CDLL. Okay. So what is CDLL? CDLL is circular doubly linked list, right? So at every root, I have to create a circular doubly linked list. Basically, it's the same linked list. I just have to link it, right? Okay, so at every node, we have to make a circular doubly linked list. So there can be two cases, right? So what can be the two cases? So for example, we are taking this particular binary tree only, right? So there can be two cases at every node. So first case could be previous equal to null. So that means that we have an empty linked list right now, and we do not have any nodes present at it. So for the first case where previous is equal to null, so that occurs when I am at 3, right? So since it is not having any left, so it will come back to the root node. Okay, so now head equal to root. So what does it mean is that we are creating a node having data equal to 3, and this is the head node, right? This is the head node that we currently have, and now we will go to its we will go to its next iteration. Okay, so while we go to the next iteration, we'll be seeing it. So we are traversing this in order traversal, right? So for the next case, there can be another so we are doing head equal to root. So now another case could be when we already have a previous, right? And also at this particular node, we are assigning our previous to the next pointer. So for earlier, our previous was equal to null, right? It was equal to null, and now my previous is equal to the head, since I'm having one node present at it. Okay, so now what we have to do is there can be a second case like this. Okay, so when I'm coming back to 1, that is, I have finished all the iterations of its left side. What I'm doing is I'm coming back to 1. So now I have to process the one root node, right? So in that case, what is the case? That is the case 2, right? Because we already, the previous is not equal to null here. So now previous is equal to the 3 node, that is the head. Okay, so in that case, what I have to do is previous right is equal to root. So what does that mean? I'm connecting its pointer, the previous pointer, to the node value, that is 1, right? And roots left is equal to previous. So what does that mean? Roots left is equal to previous. Okay, so this is what we are doing. We are at every root, we are processing that particular root node by linking it to the circular doubly linked list, and previous equal to root has to be done for every step, because that is basically we are iterating or going to the next node. So previous equal to root, what does that mean? Now my this particular previous will come over here, right? So now previous equal to 1. So again, we will go to 2, right? So now after the processing of left, it has processed its root, and now it has to go to the right. So that is 2. Okay. So here what we have, 2 again. So obviously it is the second case, right? It is the second case wherein we have the previous is not equal to null. So we will make the root node, and its previous right equal to root. Okay, roots left equal to previous, and yes, so now we have our previous equal to 2 here. Okay, so now this pointer is pointing to here, right? So now my iteration has been done. Okay, so we can see that there are no further nodes. So now what we have to do at the end, link the last node to the head of the linked list. So what is it saying is that obviously how do you access the last node? That is the previous pointer, right? So the previous pointer will always point to its last node. Okay, so now this last node has to be pointed to the head of the linked list. So I hope you are clear with this particular algorithm and the iteration we did. So this is what we'll be implementing. I'll be showing you the code once. All right, so this is what the code looks like. We have two pointers, head and previous, which is being assigned to null. Okay, so we have to follow the in order traversal, right? So, but first we have to check if the root itself is null. So the given input root itself is null. Then what we have to do? We have to just return a null from there. So we will traverse the whole the to the leftmost node. So this is how we do the in order traversal. We traverse to the left. Here we are traversing to the right, and in the middle we are processing the root. So this the same thing I've explained earlier. So if my previous is null, so there can be two cases, right? If my previous is null, in that case what I have to do is head should be equal to root. I'm basically initializing my head or the first node, right? Else what can happen is there are some nodes. So in that case I have to link this root node to its previous head, right? So in that case, previous right equal to root and roots left equal to previous. This is what we have done. I am incrementing the pointer. That is, every point I am processing the root. I will do previous equal to root. That means now my previous will be this and then again this. So this is basically updating my current pointer, right? Which is being processed. And then we'll visit the rightmost nodes. And at the end, we are just doing linking the end node to its head. So head's left is equal to previous and previous right equal to head. So this is what we are doing and we are returning this particular linked list, right? So I hope you're clear with this approach. Thank you.